Hi everyone, Wallen again. So welcome to lesson 6 of the Southville Arduino course. And today we're going to learn about ultrasonic sensors, buzzers, and a review on C++, what are functions. Okay, so just a reminder, this is what the Arduino board looks like. And then for this activity, we're going to be using the digital pins over here, primarily the digital pins over here to write and read stuff. Okay. Um, Next, this is the wiring of a breadboard. As usual, just as a guide to you. But what we're going to be talking about reviewing today is C++ functions as part of our project. So again, every function C++, it allows you to create code that you don't have to repeat. You don't have to copy paste over and over again. You can just call the function and then it will execute that code. So the first thing is a function has a return type. Is it either a void, returns nothing, an int, a long? So what is the return type? Next is the function name. Next is a list of parameters. This can be empty, but you can have parameters going to your function. And then last is the body of the function, which is here. This is the code that will run once the function is executed. This is an example function again. So here the return type is int. The function is called multiply. It takes two parameters, an int a and int b. It returns a times b. And here we are calling the function. So int result equals multiply 4, 5. We're calling that function here. So it's just a simple function as a reminder. So in this topic, we are going to be discussing two new kinds of things. First is called an ultrasonic sensor. And how it works is on Tinkercad, these things, the trigger and echo pin is the same. But on your Arduino board, you might notice 4 pins, 1, 2, 3, 4. On the Tinkercad, the virtual thing, you'll only notice 3 pins. But what it does, an ultrasonic sensor, it works by sending a sound wave and then it waits for it to bounce off an object and return to the receiver. By doing this, by sending something and waiting for it to return, we can determine how far away something is by using how long it takes for the sound waves to return. This is how sonar works as well. So why did we have to talk about functions? Well, when we'll do the project later in Tinkercad, you're going to see it automatically create this function for you. So I just like to explain how it works. So it takes it returns a long. The function name is read ultrasonic distance. It has two parameters. The trigger pin. The trigger pin is what pin will trigger the sound wave to go out. So to turn on the sound, the ultrasonic sound. And then int echo pin. The echo pin is the pin that makes sure when it's on, it's starting to listen. So first, what happens is we set the trigger pin to output, and then we set it to low. We're basically clearing the trigger or making sure it's off. And then we set the trigger to high for 10 microseconds over here. And then we set it to low. So basically, these three things will set it to high for 10 microseconds, and then set it to low. And then here, pin mode is we are actually turning on the echo pin as an input. And the travel time is will be the pulse in. It will just be this function here, which is measuring how long it takes. So the function's pulse in, echo pin, high. And basically, this function returns the round trip travel time of an ultrasonic sound pulse measured in microseconds. Next, so we take this, how long it took in microseconds, and we multiply it by this number to get the distance in centimeters. So basically, how did we get this number, 0.01723? I'll explain that in a bit. So this is how the function works. It sends a ping for 10 microseconds. It listens to the echo. It measures the time. The pulse in echo pin high will just wait for the sound wave to come back, and then it returns that value in microseconds. So next thing is, how did we get this number? 0.01723. So the speed of sound is 342.6 meters per second. We can convert that to 34,260 centimeters per second. So just by multiplying by 100. And then, so 1 microsecond is there are 1 million microseconds in 1 second. So we convert the 1 second to 1 million microseconds. So we get this number, 0.03426 centimeters per microsecond. So the round trip is just divided by 2. So 0.03426 divided by 2 gives you 0.071, which is pretty similar to what the Tinkercad code gives, which is 0.0172. So basically, this is just an explanation on where that number came. It's basically converting the microseconds, how many microseconds between the pulse wave and it coming back, and just this number gives you the distance in centimeters. Pretty cool. That's also how sonar would work. So next thing in this project, we're gonna also be learning about buzzers. So a buzzer, it's a component for generating sound. We connect it to a digital pin, and it will emit a tone when the output is high. So how does it work? Basically, there's a membrane that vibrates with current. So when the current is turned on and off very quickly, the membrane will vibrate back and forth, and this is what creates sound waves. So by changing how fast the current is turned on and off, we can control the speed of the vibration. Faster vibration is would give you a higher pitch. So basically, inside our buzzer, we have this membrane that vibrates and it creates sound. So in Arduino, another function, it's called tone. So we're going to be using this. So tone takes 3 parameters. What pin is it? What pin the output or to use to digital write from? What pin on the Arduino board? The frequency, how high pitched or low pitched it is, and the duration is how long we want it to be. Okay, so that's the Arduino tone function. And what we're going to be creating now is a pretty cool project. With these two things, we're going to be creating an alarm. So this is something that could help someone who has difficulty seeing or blind. If the object is close enough to you, this buzzer here will buzz or vibrate. And we're going to be doing this project on Tinkercad. This would be the wiring. This would be the code in Tinkercad, and these were the functions we discussed. So we're going to be setting that up now. So now let's go and create our circuits. We're going to click Create on Tinkercad. You're going to click Create, Circuits. And we're going to call this Lesson 6, Ultrasonic Sensor with Buzzer. Okay, so same thing. We're going to drag an Arduino R3 board, make it a bit smaller, and then we're going to drag a breadboard. Okay, next thing, we're going to convert this whole positive rail to have voltage. This is called the, I guess, a voltage rail. So here. So everything, this whole row now has voltage. And then we're going to have a ground rail. So I'm going to take a GND and wire the GND to the minus. So everything on the red has a voltage now. Everything on the minus is a ground rail. Okay, next thing is we're going to take an ultrasonic sensor here. So here you can see on components, there's ultrasonic distance. I'm gonna have it start on row 11. So here we're gonna zoom. You're gonna see a GND, a 5 volts, and the signal. So here's how we're going to wire it up. So the ground rail, which is black, I'll wire this to GND. Okay. Next, the power rail, I'm going to wire that to the 5 volts. And then the signal rail, I'm gonna wire that to digital pin 9. So I'll just take the signal rail. I'll just take this one. It's a bit above. I'll wire that in. So maybe I'll move it a bit down. Okay. So now our ultrasonic sensor set up. Let's now wire an alarm. So I'm gonna put the alarm on row 22. A buzzer. The buzzer in row 22. I'm gonna put it here. Okay. Next, I'm gonna wire the negative terminal to the ground, and then I'm going to put on digital pin number 5. So this will turn on the buzzer. I'll just wire it about here on the C rail. Okay, so now everything is set up on our device, and then we can now go over the code. Okay, so the code, I'll just give you the code, how it's supposed to look like. So this is what the code should look like. I'll give you 5 seconds. So 1, 2, 3, 4, 5, and then now I'm gonna go set that up. Okay, so this is what the diagram looks like, and then now let's go into the code. We're gonna use blocks plus text. So you could also see kind of how everything translates to C++. So we're gonna delete everything here, and we're gonna start fresh. We're gonna delete, okay. So now we're gonna start fresh. First, you're gonna create a variable. Click variables, create the variable, and then click create variable. I'll call that distance. So now we have a new variable, okay? And then next thing I'm gonna do is I'm going to set distance. Then I'll click input, read ultrasonic distance sensor on trigger pin, okay? And what pin did we use? What's the trigger pin wired? It is the 9 wired to here. So it's going to be on trigger pin 9. And if you see, as soon as I dragged it, it created this function for us, read ultrasonic distance. And it has this 0.01273. And the trigger pin is 9, the echo pin is 9. Okay, next we're just gonna print it to the serial monitor, so you can also see kind of what the distance is in centimeters. So I'm gonna put print the serial monitor. Variables is distance, so you can see here. Okay, so print serial monitor distance there, right? So okay, let's go back to code. So print the serial monitor with new line. Next, we're gonna create an if statement so that it only triggers when it's too near. So if, then else. Okay, so it's under control, if then else. Then we'll go to math. Here, we'll drag this, and then go to variables, distance. If distance is less than 50, then we're going to play the speaker. So we're going to play the speaker, right? So here we're going to use output and play speaker on pin 5 with tone 60 for 1 second. Else, if it's greater than 50 or it's far away, I'm going to set pin 5 to low, right? So basically, I'll turn it off. And then we're just gonna wait 1 second so it doesn't run too fast. And here we could see when we use the play speaker on pin 5, it creates this play speaker on pin 5 with tone 60. I think that's equivalent to about 523. 1 second is 1000 milliseconds. Else set digital write to low, right? So if the distance, so that's where that code went, and the delay code is here. So and then you see the tone function, you see the read ultrasonic distance function there. So now we'll try it, and let's see if it works. Okay, so let's initialize that. It's a bit far away. Then let's make it this. So you have to click this and then make it near. Make it near you, less than 50. Then you see the sound go off, and make it far. So this is pretty cool because now as well, let's try the serial monitor. You can see that when it's near, the number changes, right? So that's just the distance in centimeters. And a project like this could help someone who's sight impaired, so that, okay, if it gets too close, the buzzer can go off. And then far away, it stops. Right? Another thing you might consider is you could say, before we end, what if this tone was changed to, let's do distance. Let's just do a multiplier. Okay, let's just say distance times 5 or something. Okay, let's put that here with the tone, and let's multiply that by 5. So the tone will change depending on how near or how far it is. Okay, so here, that's a little difference, small difference, and then let's try to do the simulation. So if it's so the sound changes depending on how far away, and then it stops when it's pretty far. So at least you can even change what sound the speaker outputs by using that distance variable. So with that, that's our project, and then stay tuned. We're gonna wire it in Arduino. Thank you.